For this problem, we're given this function, f of x, and we're asked to do two things. Find the tangent line when x is 1, and find the normal line when x is 1. Now that's new, so I need to tell you what that is. If I have a function, and this is not meant to be a graph of this function, if I'm looking at this point here, the tangent line is the line that best approximates the function at that point. The normal line is going to be the line that also passes through that point and is perpendicular to the tangent line. Okay. Perpendicular to the tangent line. All right. Now, both of those lines will go through this point, so I'm going to need to find that point. I know how to find the slope of the tangent line. The slope of the tangent line will just be the derivative at 1. So I need to think about, how do I find the slope of the normal line? What's the connection between slopes of perpendicular lines? So I'm just going to write m sub norm for the slope of the normal line. And the rule is, when two lines are perpendicular, their slopes are opposite reciprocals of each other. So this is the opposite of the reciprocal of the slope of the tangent line, or the opposite of the reciprocal of f prime at 1. The only exception to that is the special case where if one of my lines is horizontal so that its slope is 0, a perpendicular line would be vertical with undefined slope. I am not stating that 0 is the opposite reciprocal of undefined and vice versa. That's just a special case. But if I have non-horizontal and non-vertical lines, we will always have this relationship with perpendicular lines that their slopes are opposite reciprocals of each other. I can see in this picture, this first line was going up, the perpendicular line is going down. It's a little bit harder to see that where the reciprocal comes in, and that's simply because the lines I drew have slopes that are pretty close to 1 and negative 1. But if that first line were a lot steeper, I'd see that in order to get a line that's perpendicular to a steep line, I need a line that's significantly less steep. And that's what's accomplished by taking the reciprocal, because then you're flipping the rise and the run. So the steep line is more rise than run, the not so steep line is more run than rise. All right, so let's go about doing this. For both slopes, I'm going to need to know what the derivative is at 1. Let me first of all just rewrite my function. That's x cubed minus 3x to the negative 1. Now I'm ready to take the derivative. I don't want to write an equal sign because the derivative isn't equal to the original function. I'll start a new line for the derivative. And that's just going to be 3x squared. That negative combines with that negative to become plus 3x to the negative 1 minus 1 is negative 2. Now, if I were just taking the derivative, I'd probably stop there. Because I'm going to be evaluating it at a point, I might choose to rewrite that second term as 3 over x squared. I find that's a little easier to plug into. Okay. So f prime at 1 will be 3 times 1 squared plus 3 divided by 1 squared. That's 3 plus 3, that's 6. Okay. So the slope of the tangent line will simply be 6. The slope of the normal line will be negative 1/6, the opposite reciprocal. Now, both of these have to pass through the same point. Whoops. That was the original function. Okay, so for both functions, we're going to have the point whose x value is 1. When I plug in 1, I get 1 plus 3 over 1. 1 plus 3 is going to be 4. So remember, we get the y value by just plugging into 1. So for the tangent line, I have the point 1, 4. I have the slope, which was f prime of 1, was just 6. I'm going to use an arbitrary point xy and my specific point 1, 4 to fill in that rise is equal to slope times run. Rise is the change in y values, so that's y minus 4 equals the slope is 6 times the run is x minus 1. All right, so that's my tangent line. For the normal line, it's the same point, but it's a different slope. So now I've got my point is still 1, 4. My slope now is negative 1, 6. So we'll get y minus 4 is equal to negative 1, 6 times x minus 1. Passing through the same point, so I use the same numbers in calculating the run and the rise, but getting a different slope. All right, so some of the homework will ask you to find tangent and normal lines. One other thing I wanted to review because it shows up in the homework, and that's just the definitions of proportional and inversely proportional. Now we've already discussed proportional because we saw that the derivative of an exponential function is proportional to the original function. So the rule is A is proportional to B if A equals K times B for some constant K. And what we saw is that if you let A be an exponential function and B be its derivative, they are in fact proportional. Pretty cool. Okay. We've also got another definition that A is inversely proportional to B. If A is K over B for some constant K. Okay. So you do have a couple of problems in the homework that just tell you that two quantities are either proportional or inversely proportional. You need to translate that into an equation. And if the constant of proportionality is given, fabulous. If not, just give it a name and write it as a variable.